So from the textbook of transport phenomena written by Bird, okay, Bird, this is a famous textbook given by him. So this is the differential volume element representation. You can see this diagram here. This is the schematic. Total cylinder is shown, and how the small volume element, that means how differential volume element has been derived. So we have seen in the last session also. So differential volume element will be the multiplication of r dr d theta and dz. R into dr into d theta into dz. See, actually this is dr into r d theta into dz. See, we have seen this r d theta is the arc length. See, actually the notation scheme r bar theta bar is subdued. There is no issue. Now, differential line elements. See, there are three differential line elements: dr, r d theta, dz. Now, differential surface elements. We need to. There will be total three surface elements, components. One is perpendicular to the r direction. Another is perpendicular to theta direction. Another is perpendicular to the z direction. So you can see dark intermediate shading. Where is intermediate? This is intermediate shading, right? This is intermediate shading. So this is perpendicular to R. This is R direction. So perpendicular to R, what will be happening? So this is this one and this one. This is arc length. So R d theta. This will be R d theta, and this will be dz. So that will be our surface. See, R and dz. Next one, the darkest portion. So this is the darkest portion. What is the perpendicular? This one and this one. So this is dz and this is dr. So similarly, perpendicular to z direction, perpendicular z direction, you have to take this portion. Okay. So this is r d theta into dr. So this is our lengths put together and differential surfaces. So here, this is very important in, now in this particular lecture, what we have seen is differential length, differential surface, and differential volume. Once you are through with the differential length or differential line elements, then rest of the things are easy. See, differential length means, suppose I write like this, differential length in cylindrical coordinates. I can write, first of all, dr. Dr will be in r direction. Okay. That means unit vector. Next one is r d theta, that will be in d theta direction. Next one will be dz, that will be in theta delta z direction. So once this is understood, the area will be formed with these two first, and this is not considered, so perpendicular to this. That means dr into r d theta. This is number one. So that means perpendicular to what? That means perpendicular to delta z. So we can say like this. Okay, so this is surface area. Next one will be what? Now you take these two, that will be another one. So r d theta into dz. Next one will be this one and this one. So dz into dr. So this is over. So this is ds1, this is ds2, this is ds3. Okay. Put together, add up everything. That is a total differential surface. So this is how we can plan.